and welcome back to our video series on data description. In our last three videos, we've looked at graphically displaying data using frequency and relative frequency bar charts for qualitative data, stem and leaf plots and histograms for continuous data. But we'd like to be able to describe our distribution. When we describe our data, we must specify our center. Where is our center located? Our shape. Do we have a symmetric shape or a skewed shape? If we have a symmetric shape, then we have a mirror image of ourselves on either side of the center. Otherwise, we have a skewed shape. Our spread. What are our maximum and minimum values? And then our unusual features. Do we have gaps? Do we have missing data? Do we have extreme observations or large clusters of data? Now, in this video, we're going to concentrate on shape and unusual features, and we'll give approximations for the center and spread. Here we have our cache on hand data. And this stem and leaf plot was created earlier in our stem and leaf plot video. Notice, we are centered at approximately 65. So we are centered somewhere around here. Our range, we take the maximum minus the minimum, 76 minus 52, that gives us a range of 24. This data looks to be a mirror image of itself. If I grab at 76 and I grab at 52 and I fold this over on itself, it fits nicely. And the crease of the data should fall right along in this 64 to 65 range. Unusual features, well, we don't have extreme observations. We don't have large clusters of data, but we do have missing data in the 56 to 57 range. Our next data set. Here we have a histogram. Now, we're centered at approximately 4. Our spread is very hard to tell, so I've gone ahead and calculated at approximately 3.92 to approximately 4.06. This shape is symmetric. If I grab this end and fold it over onto this end, it fits very well, and the crease is approximately 4. We have no unusual features. Our next data set. Here we have a center at approximately 0.35. Our spread is approximately 0 to approximately 2.12. But notice, our shape in this particular data set is now skewed to the right. And it's skewed to the right because as we follow down, we can see there's a long tail to the right. This is what skews us to the right. We're skewed in the direction of our tail. And notice, we do have some unusual features here. There's some missing data between approximately 1.75 and 2. And 2 may actually be an extreme observation. Our next data set. We're centered at approximately 0.75. But in this data set, notice our tail now goes to the left. So we are skewed left. Our spread is between approximately 0.33 and 0.99. And our unusual features in this case, there's a large concentration of data between 0.5 and 1. Our next data set. Notice, I'll start with unusual features first, because there are some unusual features here. I have 2 peaks. This is called a bimodal distribution. This suggests there are possibly 2 population groups. Now we're centered at approximately 9.44, but we have a symmetric shape. I can grab this side and fold it over onto this side, and it fits very well. My spread is approximately negative 1.32 to 21. Okay, so let's take a look at some of the data sets we've analyzed and graphed in R. Let's start with our cache on hand data. Now, we saw a stem and leaf plot of this just a few minutes ago, but we'll run our cache on hand data. And then we'll do our stem and leaf plot. And notice, same stem and leaf plot that we had just a few minutes ago. Now, we're look to be relatively symmetric, but we do have missing data in the 56 to 57 range. If we look at our histogram, we'll see that, well, the best we can do with our histogram is from 50 to 80 for our range. Now, this is because our histogram, recall, it does not retain the data like our stem and leaf plot does. We simply have counts of how many observations fall within each bin. Let's take a look at our height data. Well, when we run our height data and take our original stem and leaf plot, notice we can still see that our minimum is 122, our maximum is 179, but it's hard to tell what the shape of this data is because we only have 6 stems. And while we said that having 6 to 20 stems was good, we said that between 10 and 15 stems gives us the best looking stem and leaf plot. So let's do an extended stem and leaf plot here. And now what we can see, we still have minimum 122, maximum of 179. We have missing data in the lower 130s range. And we appear to be slightly skewed to the left. Let's take a look at our histogram. Notice we go from 120 to 180. Because we're not retaining the data, this is the best we can give for our range. But it does appear that we are slightly skewed to the left with our histogram. Let's take a look at our pressure data. And we will go ahead and run the stem and leaf plot with this. Notice here's my pressure data. My decimal point is at the bar, so I have 54.9 as my lower value, 78.7 as my upper value. So if I want the range, I take the 78.7 and subtract the 54.9. Notice this looks to be skewed to the right. I'm missing data between 72 and 73 range and between 76 and 77 range. What does our histogram look like? Here's our histogram of our pressure data. Notice my range 55 to 80 is the best I can get with a histogram because I haven't retained the data. But notice I've got this tail off to the right. This means that I am skewed to the right. Okay, that's it for this video on shape and unusual features. In the next video, we'll start looking at how we numerically calculate the center. See you then.